For the first 40 years, astronomers have lived by a strict set of rules. Rule number one: dark matter is the ghost of the universe. It is invisible glue that holds galaxies together, but it has no social life. It doesn't glow, it doesn't reflect light, and most importantly, it does not bump into anything. In the standard model known as the cold dark matter or lambda CMD, dark matter particles are like cosmic phantoms. They can pass right through you, through Earth, and even through each other without so much even as a nudge. This collisionless nature is why we call it the dark matter. But there is a problem. For years, our observations of the real galaxies haven't quite matched our computer simulations. We see things out there in the deep, dark, dense cores of strange shapes that shouldn't exist if the dark matter is as passive as we thought. Well, the new simulations are officially breaking the rules. Scientists have discovered that the dark matter might not be a lonely ghost. After all, it might be self interacting, and if it can collide with itself, the entire history of the universe looks very, very different. And let's look at the core cusp problem. To understand why this is a big deal, we have to talk about the core cusp problem. According to the old rules of the cold dark matter, the center of the galaxy should be incredibly crowded with dark matter. Gravity should pull it all into the sharp dense point, what physicists call a cusp. But when we actually look at the dwarf galaxies using telescopes like Hubble or James Webb, we don't see a sharp point. Instead, we see a smooth, flat core. It's like the dark matter in the center has been pushed away or smoothened out. For a long time, scientists tried to blame, Byronic physics, basically the idea that exploding stars, that is supernova, blow the dark matter away. But that didn't explain everything. This is where the self-interacting dark matter enters the chat. Imagine two dark matter particles flying towards each other. In the old model, they pass through like two people in a hallway who don't see each other. In the SIDM model, they actually collide. They bounce, and when they bounce, they exchange energy. The gravothermal meltdown is something that is now being discussed, and this is breaking the rules. New high resolution simulations, some published as recently as late 2024 and 2025, have shown a phenomena called the gravothermal collapse. Think of the dark matter halo, the giant cloud of dark matter surrounding a galaxy. If those particles can collide, the ones in the center start hitting each other constantly. They heat up the surrounding area and also the center. Now in space, when things get hot and lose energy in to their surroundings, they don't just stay hot, they contract. This creates a runaway effect. The collision causes the inner core to lose its support and collapse inwards. Previously, we thought dark matter halos were stable, boring structures. But these simulations show that they can experience a catastrophic where the center becomes ultra dense, far beyond what the standard model allows. It's cosmic meltdown, and it's changing the shape of the universe scaffolding. This isn't just about small galaxies. This new rule breaking behavior might solve one of the biggest mysteries in all of the astronomy, the early supermassive black hole problem. We have found massive black holes in the early universe that are so big they shouldn't have time to grow. It's like finding a fully grown oak tree in a forest that's only a week old. If the dark matter can interact and undergo this gravothermal collapse, it provides a shortcut. The collapsing dark matter core could create a massive seed. This dense pocket of matter provides a perfect gravitational trap to pull the gas and dust, sparking the birth of supermassive black hole much faster than anyone thought possible. So in 2025, data from the campaign cluster and recently the Fermi gamma ray observations have added fuel to this fire. We are seeing bubbly, violent collisions between galaxy clusters where the dark matter seems to be lagging behind or behaving sticky. If the dark matter has a cross section, basically a physical size that allows it to hit other particles, it's no longer a ghost, it's a participant in our development. And so, where do we go from here? The rules are being rewritten in real time. We are moving from dark matter is bored era to dark matter is complex era. Physicists are now looking for specific signals, which is gamma ray. If the dark matter particle collide, some theories suggest they might annihilate each other, releasing a tiny burst of high energy light. And therefore, in late 2025, researchers using Fermi telescopes detected a mysterious glow at the center of the Milky Way that fits this collision profile perfectly. By 2026, with the opening of Cherenkov telescope array in Chile, we might finally get the proof. We aren't just looking for the particle anymore, we are looking for the dark sector, a whole world of physics where dark matter has its own force and its own rule. So in conclusion, universe is a lot more crowded than we thought. For years, we viewed dark matter as the silent stage upon which the real matter performed, but now the stage itself is moving. It's colliding, it's collapsing, and it's heating up. Dark matter is breaking the rules, and in doing so, it's finally giving us the clues we need to solve the greatest mystery in history. So, friends, what do you think? Is the dark matter just a simple particle, or are we looking at the hidden dark chemistry that we are only just beginning to understand? Let me know your comments. And if you want to stay updated on the latest breakthrough in the cosmos, hit that subscribe button. And universe is getting weirder every day, so that you don't miss out even a single second of our next video. See you in the next one.